Using algebra to find the inverse of a one-to-one function can be difficult, but we can define an inverse function graphically without ever identifying its equation algebraically. We know that inverse functions swap domain and range. This means that inverse functions swap inputs and outputs. So, if A is an input of f, then A is an output of f inverse. And if B is an output of f, then B is an input of f inverse. In other words, if the ordered pair AB is a point on the graph of f, then we can swap the input and output, and the ordered pair BA will be a point on the graph of f inverse. Let's use this property to graph the inverse of a one-to-one function. From this graph of f of x, we can see that f passes both the vertical and horizontal line tests. So f is a one-to-one function. This means we can swap inputs and outputs to plot points on the graph of f inverse. Since the ordered pair 2, 4 is a point on the graph of f, we swap x and y to get the point 4, 2 on the graph of f inverse. Likewise, since 3, 9 is a point on the graph of f, swapping x and y gives us the point 9, 3 on the graph of f inverse. And since 4, 16 is a point on the graph of f, we can swap x and y to get the point 16, 4 on the graph of f inverse. With just these 3 points, the shape of f inverse is emerging, but the behavior near the origin is not obvious. We know that the graphs of inverse functions are reflections of one another about the line y equals x, so let's include this line in our graph. Looking closely at this region, we see that the graph of y equals x intersects the graph of f at the point 0, 0. This means that the graph of f inverse also passes through the point 0, 0. Or we can think in terms of swapping inputs and outputs and realize that the point 0, 0 does not change. So the graphs of f and f inverse intersect at this point. Likewise, the graphs of f and f inverse will intersect at the point 1, 1. So now we're ready to sketch the graph of f inverse. By connecting the mapped points with a smooth curve, we see that the two graphs are indeed reflections of one another about the line y equals x. So this new curve graphically defines f inverse of x.